Hi, my name is Aditi Vijaysekara. My Khan Academy video was from problem set 6, question 5. This is the aqueous ionic equilibrium chapter, and this problem is focusing on titrating a weak base with a strong acid. The question states you conduct a titration of 25.0 milliliters of 0.175 molar ammonia by adding 0.150 molar hydroiodic acid. So in this problem, we're given the volume of the analyte, the ammonia, which is 25.0 milliliters, the concentration of ammonia, which is 0.175 molar, so that's in moles over liter, and the concentration of the titrant hydroiodic acid, which is 0.150 molar, and which is once again in moles over liter. So I'm going to analyze each step A, B, and C as we go. So part A asks, what is the chemical reaction that's happening during the titration? And so we just have to write out the chemical reaction that represents the titration itself. And so we have NH3 plus HI, which are the reactants, yields NH4 plus and I minus. And so the approach that we took is just adding together our two reactants, and the products we get are ammonium and the iodide ion. And for part B, it's asking us what the initial pH is before any acid is added. To preface, we know that if there's just base in the flask, that the pH should be basic and greater than 7. And basically what we're going to do is set up a rice table to help us eventually find the pH of the sample. So we have our equations that we're using. The base dissociation constant equals the concentration of the products over reactants. POH equals negative log of OH minus concentration, and pH plus POH gives 14. So now we create our rice table, and our reaction that we write is NH3 plus water gives NH4 plus and OH minus. We fill out our rice table using 0.175 as the initial concentration of NH3. When we go to write our equilibrium expression, we use the base dissociation constant for NH3, which is 1.76 times 10 to the negative 5. We equate this to x squared over 0.175 minus x, but we can cancel out the x in the denominator because we're assuming that x is small. We then can multiply by 0.175 to isolate x squared, and then take the square root to find x, which is 1.75 times 10 to the negative 3 molar, which is equal to the concentration of OH minus. We then can take the POH, which is the negative log of this, and get 2.757, subtract that from 14 to get a pH of 11.243. This makes sense that it's basic because we have not yet added any acid. So for part C, it's asking us what the pH would be after we add 5 milliliters of hydroiodic acid. As a general concept, we know that the pH we end with here is going to be less basic than our original from part B because we were adding an acid. So the pH of this component should be less than in part B. In this problem, our approach is going to be to find the number of moles left of the substance so we can calculate new concentrations of the base and acid, and then use the Henderson-Hasselbalch equation to find the new pH. Equations we're using are the Henderson-Hasselbalch equation, where Ka is the acid dissociation constant, molarity equals moles over liter, and Kw is the equilibrium constant is equal to Ka times Kb, which is equal to 1 times 10 to the negative 14. So we write out our equation, NH3 plus H plus gives NH4 plus, and then we find the number of moles of both reactants, NH3 and H plus. The moles of NH3 is equal to the volume that we started with, 0.0250 liters times the molarity of the NH3. And for H plus, we only had 5 milliliters of acid times 0.150 molar to give 0.00075 moles of H plus. We subtract this amount from the moles of NH3 to find how many moles of NH3 are left after all 5 milliliters of acid are added. Now we need to find the new concentrations by dividing the moles that we just calculated over the new volume, which is adding 5 milliliters to the 25 milliliters of base that we originally had. And we have our new concentrations. We can use Henderson-Hasselbalch, but we need to find the Ka value. And so we use the Kb value of NH3 to get the Ka value. And now use Henderson-Hasselbalch, we find that the pH is 9.93, which is less basic than the original, which makes sense because acid was added. And so those are the 3 parts of the video. This was a problem where we titrated a weak base with a strong acid. In part A, we were asked about the chemical reaction that occurs during the titration. And we received our answer by considering the reactants and products. We got NH3 plus HI yields NH4 plus I minus. For part B, we were asked about the initial pH before the acid was added. And we used a Rice table. And we calculated the pH of the solution was 11.243, which makes sense because no acid was added. And C, we had to find what the pH of the solution was after adding 5 milliliters of acid. We found the number of moles of the substance, calculated new molarities, and then used Henderson-Hasselbalch to find the new pH. We got 9.93, which makes sense because adding on strong acid decreased the pH. Thank you.